This video we're going to talk about solving systems of inequalities. The method is that we graph the boundaries of each inequality, which is to graph the inequality itself. And then our final answer will be the shaded region that contains solutions valid for all inequalities in the system, meaning only the area at which all the shading overlapped. So here is the system of inequalities, and we've discussed in previous lessons about how to graph a single inequality, but now we're going to graph the system. So first of all, I would rather have this with the y on the left-hand side, the inequality symbol, and then the rest of the expression on the right-hand side. And I'm doing that with both inequalities. And now using graph paper, that's important that whenever you're graphing for solving any kind of a system, whether it's inequalities or equalities, you have to actually use graph paper. So I'm graphing the first inequality, the y less than negative 2x plus 3, and that would be all of that green shaded area. And notice that the line is a dashed line because this is less than and not equal to, so it's a dashed line. The second boundary, which is the y greater than x minus 3, I graphed x minus 3, and to have all the y's that are greater than that, I shade all that pink area there. And I'm only interested where these two shaded areas overlap, which is over here, so our final answer is simply that shaded region. Please note that I have erased all of the other shading. My final answer only shows the shaded region that is true for both inequalities. The second system of inequalities, I note that I have an absolute value. Once again, I rewrote it with y on the left-hand side, the inequality symbol, and then the absolute value. Noticing that that's just the v, the absolute value v, has been moved to the left 3 units. So I'm going to graph that absolute value. Again, a dashed line because we do not have an equal sign, we have just a less than symbol. Shading all of the area that is less than that, meaning any points in this yellow region would be true for that first inequality. I graph the second inequality, the 2x minus 1, and I want all the y's that are above that line, so I have that done in green. And we're looking at where did these two areas overlap, which is in this section here. So our final answer is this. This is our final answer here, showing that in this area, any point, any x and y coordinate in this area would be true, would give a true statement for either one of those two inequalities.